Yes, we are live. So basically, yeah, I was working last week with this plugin board, and then I got some motors working, and then right now when I'm connecting the encoder, so yeah, sure, we were running a parallel uh, track so that we could get the software ready while we are preparing the hardware. So we bought this Tumbler platform, but then it had this problem of it had this normal Arduino which was running on 5 volts. So I designed a small plug-in board which has a voltage translator in between, and then basically we have this Arduino Nano ESP32 with that plug-in board plugged into the Tumbler main PCB. So that way we can start already with the software part, and while we are designing the hardware. And then basically I designed it from China, and then got the uh, board here, and then it had some bugs, so I fixed that. And right now I'm basically trying to port all the software from that Tumbler to this Arduino ESP32. So I got the basic motors working, but when I right now last week when I was connecting the encoder to know the rotations of the motor, the ESP32 crashes. So I've not been able to figure out what is the problem there. So basically today I was trying to attach some debugger to the ESP32 Nano, the Arduino Nano, and then figure out where is it crashing. That's the
Debugger.
situation with. Well, yeah. So the new Arduino has this debugger. I think it uses OpenOCD, but it has a lot of problems. And then I tried Platform IO. It also has a lot of problems. But then probably tomorrow I'll directly use OpenOCD. It's the fastest to use it.
Yeah, Espressif is not particularly friendly to in-circuit debugging. So they have like a I think there's a E fuse you have to burn to even turn on hardware JTAG, and then your board may or may
Hmm.
not even have that broken out.
I think the newer ones, the ESP32S3, they have a built-in JTAG that comes via the USB. So that way it's so I've used that
I've
with the
just
Freno kit.
got you.
So I set
Yeah,
up,
we
yeah.
no.
So I set
The
that up.
reason I laugh is we've gotten bitten by that a lot with low power stuff. So it's just not
Okay.
usable if it goes into deep sleep. But if you got it to use, if you got it working in the runtime when it's on, that's great. You can get it working.
So, but yeah, I don't use like this platform IO and the Arduino GUI itself. They do a lot of stuff, and it's a headache to use it with them. So when I think 6 months ago when I was using it, I was just using the command line OpenOCD, and then directly using it, and then started up a GDP server. I was using it that way. So that was faster than figuring out what's wrong with the Arduino IDE and Platform IO. Because on Windows, I think when it tries to connect via the USB, the inbuilt USB JTAG, I think Windows USB driver has some problems, due to which it is not able to open up the JTAG or OpenOCD. But then I had a virtual machine. What I did was did it with Ubuntu. But yeah, with Windows, it has been a headache for me. So today, the entire day was trying to figure out uh, basically what's the problem with the USB drivers.
Yeah, I mean, as terrible as it might be, honestly, with the expressive stuff, printf has kind of been the the trusted.
Yeah, but the problem, like I tried to initially get that printf working, but I couldn't get that with the Arduino framework working. So it's basically when the ESP boots up, it prints out some logs, right? The initial logs.
Yeah,
So I couldn't get the debug logs out. The normal prints work, but not the debug logs, because when it crashes, it prints out the trace on the normal UART.
yeah.
But so I don't know what the Arduino framework is doing, there is some config that you have to set it up so that you can get the debug traces out while it's crashing.
Are you wait? Are you using? You're using like a Freenove like Espressif board?
No, the Arduino Nano. Uh,
Oh, like a generic Arduino Nano. Like you use a
Nano
special
ESP32.
with the U blocks module. That's an Espressif.
Yes,
Got it.
I think it's this one.
Got it. So that doesn't have a native USB PHY, and it's going through a it's go,
I think it has a so the USB directly connects to the ESP32. So I've
oh
been
yeah,
able
it
to
is.
connect
It's an S3. Yeah.
it. Yes, it's an S3, so it does connect. But I think the UART somehow needs to be configured so that the debug traces come out. So you can that normally use the USB UART. So you can, like, if you print something with the UART serial, it will come out, but not the debug traces. For that, there is some special configuration you have to set so that debug traces come out via the USB.
Yeah. So yeah, in this kind of application, um, USB is always problematic because there is a port bring up time on the host. So like whenever it comes in and out of sleep or gets reset, oftentimes there's going to be an enumeration period of like a couple hundred milliseconds where the port has to come up. So if you're actually trying to get sort of time accurate debug messages, the only way is to use a hardware serial port.
Okay. So basically, I will have to. So there is two extra pins for RxTX. So I might have to get it out through the second serial port then.
Yeah. So the recommended development workflow for this target from Espressif is to use their ESP and it's like a $12 programming tool. And that little board, it's literally just an FTDI, but it has like the right pins to connect to the Espressif target, and it gets you both the serial, the UART, as well as JTAG if you actually do want to use 5-layer JTAG. But if you get one of those ESP progs, and then
Actually,
you
I
need
have
to
it.
use that,
Yeah.
you don't. I mean, you don't have to use the actual ESP prog, but you just need to have a hardware like like an FTDI connected to the hardware serial port, and print through
Okay.
that. That's the only thing that will reliably work 100% of the time every time.
Mm.
Trying to do it over
So yeah, I was
USB is
actually like
convenient.
I was
Yeah.
I was so when the ESP32 boots up. So what I had, I'll show you what was initially happening. So I have this switch. So this is the board. I had a simple board designed. So these are the level shifters. On one side, I have the ESP32, and then the other side plugs in to the board.
Awesome.
And then I had some bugs. So initially, what was happening was, so it would start run. It would start to run even before the ESP32 would boot, because the level shifters have an enable pin, and they would immediately start if I have the board connected. So they would start. The motors would start running even if the ESP32 had not booted up. So basically, I used to wonder, like, what is happening in the first 1 second or something before it starts actually running. So what I did was this made a cut on the enable pin of the level shifters, and then I added a switch in between.
Nice. So this Tumblr, is everyone building this platform from the
I think
PCBA?
3 of us have it.
Yeah, I have one which I did the basic assembly, and I think my only mod on it is adding an ultrasonic, or sorry, a beeper. That was one of our early experiments, making it beep when it got too close to an obstacle. But since then, yeah, what Anurag is doing is the big project. And Mayor, have you done anything more with yours?
No, it's just
And
sitting here.
is it a balancing or a caster base? Does it have a tail?
No,
It's a self-balancing here.
It does have a tail, but it's balancing. And one of our first ideas for projects was actually get rid of the balancing mode and recode it to do it your way, which is, use the tail as the counter torque. Because the balancing, yeah, it does make
That's
it.
right. This
Yeah.
was the concept. Yeah. This
Yeah.
was the. Mm-hmm.
But the balancing is pretty robust. Even if you put, like, I don't know, a glass of water on it and stuff, it sort of manages. But it's like kind of unnecessary. And I think like a trailing caster or even just dragging the tail along might be a more robust thing and closer to what you were suggesting we do.
It
Yeah,
reminds
this is
me
almost
of,
like a replica of the Yakasaur design.
yeah. It reminds me of if you recall the first year of the DARPA Grand Challenge. I think this was like 2004. No, what? Does anybody remember the DARPA Grand, the first one in the desert with
Yeah, I think it was around 2004. I remember. Yeah,
it was 2004?
I think so.
Yeah, okay, got it. Okay, I do have a memory sometimes. Um uh most of the entrants were four wheels, right? They were like cars and Humvees. But the one entrant, the motorcycle, Anthony Lewandowski's entry, um, self balancing. So he was attempting to solve self balancing and full autonomy through desert terrain at the same time, and it had this very interesting like self writing thing. And then I just remember in the documentary, they have like this like sad moment where the robot's like trying to self right itself, but it's like stuck in just the right ditch that like its little self righting arm can't get it back on the two wheels. But there's this sort of balancing robot.
I actually don't get the benefit of self-balancing for rover type applications. Like rovers are slow, and I guess two wheels might give you a little bit more agility over certain obstacles, but in general, I don't see the point. Uh, Self-balancing is good for, I think, higher speed, maneuverable applications. I don't know. Maybe you have a.
I mean, this is a whole separate discussion about robotics right now and humanoids, but I think the one short thing I'll say about that is I am particular kind of like a humanoid doomer, and don't subscribe. But like one of my favorite examples I point to there is there's a, I think they're Swiss, this is a Swiss guy. He has this robot he calls a Cento, which is kind of it's a wheeled legged, but it's like a large diameter wheel, so it's like a bike tire, like a BMX bike tire, and it's balancing. But if you look up Cento, you'll see it can kind of like go up and down stairs and stuff on its wheels that is balancing on. So it really is like a balancing wheeled rover. The important part is it's wheeled legged, so like the wheels are on really high travel legs, so it can still kind of like deal with logs and stuff.
What's the spelling? How do you spell Cento?
Um, Let me make sure. ASCENTO, a Cento robot. So this is like the poor man's spot because it doesn't have to have so many freaking actuators. I'm on mobile otherwise if somebody else wants to show it, but this is like a wheeled-legged security rover.
Can you drop the link on the Discord?
I dropped the link in the chat. It looks like a wheelchair basically.
Yeah, kind of, but like with 12, 15 inches of, like a solid, almost half a meter of travel, so it can like jump and stuff. But I just bring it up as a like inverted pendulum robot as a concept isn't dead for this sort of an application.
Mm.
I like how it sits up and raises its center of gravity. Very interesting gesture.
This is similar to. Do you know the X-Go rider? I'll drop the link. Can you share, Venkat?
Yep.
It's in the.
Oh, this is a little desktop thing.
Yeah.
So it's kind of
every meeting. There's one new robot I want to buy.
You got to earn your points first.
These X-Go people also have a robot dog.
So this is really filling the vacuum that the oh man, I'm blanking. I have their soldering iron. I bought the soldering iron in the liquidation sale. Anki.
Anki, yeah.
This is kind of filling the vacuum of the Anki robot. Anki like not being a company anymore. Cosmo.
What was that?
Anki Cosmo. This reminds me a lot of Cosmo. So Anki was this company that existed, I don't know, like 5 years ago, and they made this sort of like, it wasn't really targeted towards kids. It was really like for adults. It was kind of like a for adults little desktop robot. And they ultimately failed. I think they it wasn't venture scale, and they were trying to be venture scale. But it seems like a similar vibe. It's like a for adults toy robot.
It seems to be still available.
That's cool.
It's tracked with a.
Yeah, it's got a kind of a Wall-E vibe to it. Wall-E design language.
Yeah, but I guess we should have a discussion at some point about like wheeled versus legged and balancing versus non-balancing. So interesting 2x2 there. Like the advantages of each. So legged and balancing is humanoid. Legged and non-balancing is, I guess, minimum 6-leg insectoids or something with the tripod gait. Then you have the other two quadrants.
Yeah, I've never seen a kangaroo so far that I can think of.
Oh no, we have.
Kangaroo as in like 3 legs basically?
Yeah, or like a cento with a tail kind of a thing. Because kangaroos use their tail is like highly structural.
Mm-hmm.
So that's what I mean. That kind of a kinematics is what I'm saying. I haven't really seen.
Okay, this Ascento can also, like, even if it flips, it can still keep going around, right?
Yes, I believe so. maybe in not quite as creepy of a way as New Atlas, but yeah.
Okay, I found a video. Let me share that.
Of the kangaroo robot?
No, the Ascento, like this looks better than the one on their website.
Oh, big.
So it went faster than the spot. That was an interesting bit of trash talking.
How much does this cost?
I have no idea.
It looked like you rent it by the hour.
4.3 million? Oh, that's a company.
Oh, no, that's the funding they've raised. Yeah, this is. I don't know. It feels kind of Segway-like to me.
Okay, Josh, I put here two kangaroo robots. And it turns out Festo has, every year they come up with new robot designs.
Yeah, I never figured that out, honestly. I don't know. I've never met anybody from Festo. I feel like they have this like cool demos division. And I don't quite know where it comes from, but they just consistently make really cool demos every year.
It says here that they have a sprawling secret German laboratory there. Now, I know Festo because there's a famous patent case called Festo. But, I mean, you
Is it
might
the same Festo?
Connect to this. So the second link from IEEE is.
Hold on.
Yeah, that's pretty cool. So I guess I do have one question about the tumbler. What wasn't the existing off-the-shelf tumbler doing, where you developed a custom board?
We wanted to change the brains, right? It has a normal Arduino with the AVR core, and then we wanted to change it to ESP32 because Yakasaur has the same brain. But then basically we found out that the tumbler PCB runs on 5 volts, but the ESP32 is running on 3.3. And
Yes.
then basically, yeah, I designed a small board. It was a good practice learning experience, getting it manufactured from China, getting it here. It's really cheap to get these proto boards from there.
Yes. Yeah, a friend of mine was joking. Well, we were not so joking that we could just have a every commit on push to the repo, it just orders a new board. Got you. I see. So it was really the target. Swapping out the target was the main motivation.
Yeah. So basically, like if I get some more of the code working, I might design the entire tumbler board uh, with and remove the plug-in board itself because it has some bugs and I had to make some cuts here and there. So I could just make the entire board itself working on 3.3 volts. Yeah. So, and I also bought a LiDAR scanner. It was available in $10 or something on eBay. So I bought two of them. It's a 2D LiDAR scanner for $10. So I got
2D
two of
LiDAR,
them.
$10 LiDAR. Wait, what?
I think now it's around $20 or something, but it's still a good deal. I should have bought four.
Do they work?
I think the guy who posted it on Twitter was saying it's working in his garage. So hopefully it will work. But it will arrive next week or after that. So it's coming from somewhere in Ireland. I think it's. I put the link in our the main YaRG channel.
Yeah, I'm very curious. I know the vacuum cleaners are still going strong, but I didn't realize it was getting that cheap.
No, but the normal price is around $70 or $80. This is I don't know. This is some deal they are making. So and like by the time I bought it, like 250 units in like 1 hour were already gone. Then the guy or the company that is selling it increased it to, I think now it's selling it around 20 or something.
Got you.
Yeah, now it's around 27. So 11,000 pieces have gone out.
This is a weird sales strategy. Start really low, then increase it $10 a week. Right. And maybe they're trying to do
I mean, it
price
worked on Entourage. How many did he buy? He wishes he bought more.
Like I thought it okay. Will I use it or not? But then I thought okay, it's $10. I'll just buy it.
Twitter fire sale marketing, still cheaper than ads. Got you. So is that kind of that's the state of the art then? Is working on the motherboard that still runs on the Tumblr?
Tumblr, yeah, and then basically we could design while the hardware for Yakasaur is getting ready. We could already start experiment with the software, right? Yeah, so that was the idea. But
I've got
There's
a parallel
one other
path for
thread.
development.
Oh, go ahead. Red.
I was gonna say I've got a parallel path because I didn't have the Tumblr, and so I was working on one of my existing rovers to power it via the ESP32 board that Freenode won, and so I've been working on a PCB. If I can get it to show up in the thing, just to try to figure out if I can make a PCB that'll actually work. And I just got it soldered today, so we'll see what it does. But I ordered mine from Osh Park, so it's very pretty. However, it was $35 for my 3 boards, so it's a little pricey, and I have to assemble it myself.
Can you try to
show the board?
Again? Yeah.
Can you show the board?
Yeah, let me see if I can get my phone to do the. Can I broadcast from my phone? Maybe not. Let me try this. No, all right, gotta turn off the background.
What are you guys designing in? Are you using a KiCad or Flux or something?
Yeah, I started with Flux. Then I was getting confused, so I left it. And KiCad I was already familiar with. So then,
cool.
I just used KiCad. And then KiCad has these export tools. These PCB companies have made their own plugins, so they generate their own production files. It generates the production files, and then it goes directly to those companies.
Look at this quality soldering.
Right, I think I missed the session where you talked about this. What does your board do?
So mine is actually, let me grab my other rover here. So, well, first off, it's mostly an excuse to build a board. But if you remember from this rover, I had this like prototyping. What do you call this? The stacks.
Earthboard.
Yeah, but like the stacks on top of an Arduino, and so I had put the motor driver, the L293D or whatever it is, and just this rat's nest of wires, and there's the wires are soldered, so it was slightly more reliable than the breadboard solution. But so I wanted to try to do something like that, but as a PCB, and this one can drive 4 motors instead of 2, because I wanted to see if I could actually make a rover that is not our 2-wheeled variety, to see how that would work out.
Share the schematic on KiCad or whatever.
Yeah, let me pull it up. Did that pull up? There we go. As I was assembling this, however, I realized though I had used that L293D before, I didn't actually pull up the datasheet and read through it again. And I have very little faith that this is actually going to work how I have it wired up. And I also didn't do any of the guidelines. But we'll see. I was able to assemble it. That was the biggest thing.
So
but you haven't tried to run the motors yet?
No, not yet. It looks like it boots up. That's as far as I've gotten.
So you basically combine 2 motor breakout boards along with the Arduino in a neat package.
Yes.
Okay.
I think if I and again, this was like to see how fast I could actually produce a board. I think if I were to do a second round, because this probably isn't going to work, I would go shopping for a chip that would actually do what I want altogether instead of these two chips. So it seems like it's possible to find those, but it might be a little bit more involved to wire them together.
You could just add transistors, right? Basically, L293D is a set of transistors.
True. But, oh yeah, so the other problem was that it uses so many pins to control that I felt like I was wasting a lot, so I really wanted like something that spoke I2C or something. And that would also make wiring a lot simpler.
Are those you can directly drive those with 3.3?
That's the problem that I just realized from reading the data sheet that we're about to find out whether it works or not. I forgot that when I used these before, it was with the other Arduino that's 5 volt.
Wait, I thought 293s have like a separate power line that goes to the motor and you just send the control signals from the controller, right?
Yeah, but the logic level is rated at 5 volts, not 3.3 volts.
Oh, okay. So there's a logic level mismatch as well.
Yeah.
But the drive current or drive voltage can go as high as 12, if I remember. And then if you want to go higher, there's a different, not the 293, the other one. And, okay.
Yeah.
Yeah, we probably need something like this for the Yakasaur.
Yeah, where's the 3.3 domain? And I don't, how do you get 3.3 on this? I see the 5 volts in on the battery. But do you have a regulator somewhere?
I'm using the onboard regulator on the Freno chip that supports legs. So the 5 volt pin on, oh shit.
Oh, you're not using I see. It's like the Freno header situation.
Right. This is, yeah. That well, yeah. So it just sits on top of it on headers. So yeah, they broke out what they labeled as a 5 volt pin, but if you look at the bottom of it, it's like into this voltage regulator that when I read that one up, it Should support, and that actually looks like it works. So at least I've got that.
So your footprint fit exactly as you designed it, right?
The footprint worked, and it powers up. And the other feature of the board is this voltage divider that lets me measure the voltage on the battery that's powering it. Which I did actually breadboard that out, which seemed like it worked. But I'll let the onboard software tell what the voltage on the battery is, which is kind of cool. So I think that'll work.
Oh yeah, that reminds me. I think last time you were on the call, Yasha, you were discussing like some power management as the bottleneck of Yakasaur type designs. Like you were showing us some kind of expensive power management monitoring thing. I forget what it was. The other thing I wanted to ask you while you're here is, I think we discussed solar and power packs last time you joined. There was like some cell phone looking thing with a solar panel and battery integrated. And I think we were looking for that at one point, but forgot what you'd mentioned. Like I bought like an Adafruit solar panel chargery kit thingy, but I was looking for the one you mentioned and I couldn't find it. What was that? And yeah, remind us again what you were saying about the, I guess, power management thing.
Yeah, I mean, I don't remember exactly. There's a few things. Generally, if you are trying to conserve your power, you're going to be controlling all your power domains, and usually you're going to have some kind of a load switch going on. So you'll have your high level system controller, which sounds like in this case is going to be the Espressif, and maybe you'll have that control all of the other power domains, whether it be for radios or higher power compute or other things. But yeah, there's lots of parts you can get that they're specifically designed to be a high side load switch to enable turning things on and off. And when it's off, it's like really off, very low leakage to conserve power. I think that's probably what I was mentioning then. Just making sure you have a solid load switch to shut everything off completely. Yeah, the other one was solar, and that's a whole topic, and I've had to get pretty deep into that for a work project of mine. Generally speaking, though, if you want something like this, this is still laying around. This has been sitting in the hot sun for so long now. The battery's starting to swell and bow out the solar panel. That's fun. But yeah, this just like power pack thing.
What's the brand of this? Or what is it? Can you buy this thing?
I think I got this at a trade show free.
That's what you told us in the past, yeah.
Okay, that's why I couldn't find it. I went looking for something. I don't know what I googled, but I couldn't find this.
But if you just search like power bank and like solar power bank or solar cell phone charger, solar power bank, you'll get this.
Okay.
And like generally,
these are cell phone specific, and they produce what, like 5-volt USB to charge cell phones. Is that how these are set up? Okay.
Yeah. So it's got these ports here,
Okay.
But generally speaking, if you really want to be cheap and use parts that are available from LCSC, like if you're building boards with PCBWay, and if you're also going to use their assembly service, which I would highly recommend for a project like this, they're going to have a standard library of parts available. If you look at PCBWay, JLC PCB, PCBWay is also an option, but not as turnkey. So if you use JLC PCB's service, use their assembly service, and they have a parts library that's like standard off-the-shelf parts that they have. The thing is, if you're designing circuit boards in like the US or Europe, the part supply chains tend to vary a little bit between Asia and like US, EU. So like LCSC, they have a lot of parts that are like the Asia alternate. They're really cheap. And one example part for this application might be a solar charger, like power management IC. There's probably some super cheap linear charger you could find there that you could just design into your board. Otherwise, the catch with JLC is it's really fast and cheap and all that, but if you're doing assembly with them, if they don't have the part in their little part library, consigning parts to them is like, it breaks the magic of the process. So usually what you'll do is like design around that, or design around that as much as possible, and then assemble the last few parts that they can't put on yourself. But for a solar panel, like the simplest thing you can do is just find a little linear charger that's not going to be very efficient, but it does the job. And I could almost guarantee that's what's inside this thing. It's some cheap linear battery charger. And then it's pretty straightforward. Like, you just gotta make sure your solar panel isn't gonna leak backwards when it's nighttime, and you can kind of look up some reference circuits for that. And then just get a little linear battery charger, and I'm sure that Adafruit board has this all figured out. And then you can just very easily use a generic solar panel and go from there. If you want to get fancy about it, there's a lot of crazy stuff you can do with solar panels and energy harvesting. There's a lot of chips these days that do a really great job, but they get pretty expensive really quickly, and they can get pretty complicated.
Yeah, I think it's like basic solar is an obvious next step after Anuraj and Rhett figure out PCBs. Like, once we do things like voltage shifting, things like that, natural next step is to connect up solar. So just trying to do one step ahead thinking.
We were also discussing about the voltage of the motors, right? Like it was, I think, like initially there was some 12 volts, but these tumbler boards have this 6 volts. So basically, we don't know what's the difference it would make. It's just the torque difference, right?
If you run a 12-volt motor at 6 volts, the only side effect will be the top speed is going to be limited. If you run a 6-volt motor at 12 volts, the top speed is going to be overspeed. And the only thing you got to watch out for, again, like, motors are always thermally limited, so there isn't an inherent issue with running them at different voltages. It's just going to be a lot easier to get a 6-volt motor to overheat running it at 12 volts, because the winding resistance isn't going to be sized for that. But like most motors, if you run them full current, dead short, they will overheat, guaranteed. So there isn't like a problem with that per se, as long as you're doing your PWM speed control within reason.
But then this connects to the solar charging circuit, right? So with 12 volts, we will have to step it up. And then this ties into the power budget circuitry.
It's also like if you have 12-volt motors and you have a 6-volt rail, but you're only ever going to go at 20% speed, then there's no issue, because you're not going to be limited. It's just if you need to go over 50% speed that you could have problems.
So wait, I want to get this power straight. So you'll have solar feeding a battery, and the solar output and battery charging input will be the same, or I don't know if there's voltage transitions between them, but on the output side, you should size or have the battery voltage be this, like what's typically done here. Like if you wanted to run a Yakasaur sized rover, what voltage should the solar panels deliver? What should be the voltage the battery runs at? What's the power rail, and what's stepped up or down? Like, I guess I'm looking for the sensible defaults here.
The by far simplest thing to do is to not convert rails if you don't have to, because there's always additional parts and efficiency and losses there. So like the easiest thing to do, and by the way, the moment you have batteries in series, you have to think about the concept of them going out of balance. Like that's not always a critical concern, but the best problems are problems that can't exist. So the easiest thing is to just have one S battery. So it would be a single
That's
cell in parallel.
3.7, is it? No, 4. Yeah, right. So
Yeah, it's going to be between like 3.7 4 volts kind of a thing. Typically in your, we can look at the discharge curve, but the point there is, if you're doing a linear charger from a solar panel into that battery, you need to have a solar panel that under your typical operating condition is going to have a open circuit output voltage that's higher than that battery voltage. So typically in a thing like this, you're going to be using at least a 6 volt solar panel, which that is not the actual voltage, right? But there's like solar panel open circuit voltage, and then there's the MPP voltage. Because like I don't know if are we all familiar with the concept of solar panel maximum power point?
yep. I think we had a session talking about that stuff.
Yeah, but I have forgotten
Yeah.
about it.
That
Yeah,
was
it's
weeks
just
ago.
like,
Can't remember anything.
I mean, TLDR is just like usually the voltage of a solar panel, if you're pulling power out of it at its peak power point, it's going to be some fraction of the open circuit voltage. Let's say it's like 30% less. So if it's a 6 volt solar panel, the MPP is going to be at 4 volts, and that'll go through a linear charger into the battery. So that's kind of like the general back of the envelope there.
And then we have to step up the voltage for the motors then, right? From the battery.
I wouldn't. I would
So
just
you
draw it straight off the battery.
so it will just not reach the peak speed, right?
Right. And you could compensate for that by reducing the gearbox reduction, or rewinding, getting a motor that's wound for that voltage. Like there's different things you could do to compensate for that. It's like whenever you're sizing a motor, it's always what's the power output, and then you have your voltage current, I guess the electrical power, and then you need to like match that voltage current through a gearbox to the torque and speed output. Power in, power out. So it's like, I mean, this is that tumbler robot has the little circular motors with a gearbox on the end, right? The planetary.
Yeah, it's the same that you suggested, but it runs on 6 volts. So it's a high tech GA37520. I don't know if you recognize
Yeah.
the numbers.
Yeah. That generic. Yeah.
Yeah.
Those will run. It's
They'll
just
run
a
at
matter of
they'll run at 3.7.
totally. They'll totally run. They just won't. They won't be able to hit their top speed.
But they'll have enough torque to actually move, right? Because the few times I've played with motors, if you give them too low of a voltage, they just don't have enough torque to do much. So will that be? So I guess
Well,
that's
it's
a
a good.
question for experiments.
Well, that's a good question. So it's like if you say, "Oh, it's a 6 volt," and then we only run it at 4 volts, we don't get our top speed. So then we reduce the gearbox. Then it becomes a less torquey motor, and perhaps there's an issue because the gearbox reduction, we changed it to make up for the speed, but then we lost some of the torque. So that could be an issue.
And also, if for a rover application, we kind of have to size it for like minimum obstacles that you want to overcome. So you do want to rate it for like and a peak roughness of terrain as opposed to like median.
Yeah.
So yeah,
Rate it for burnouts. Yeah. To be
So is
able
it
to,
possible to customize these kinds of motors with the specific gear reduction and then ratings?
Yeah, if you go on AliExpress or like you find some vendor on Alibaba and tell them you want to buy 10,000 later on, they'll make you like. Not that I'm saying do that, but
It might happen. We might need that many. You never know.
it's an honest answer. Yeah, like no, you don't have to bother a motor manufacturer, but on AliExpress and eBay, they'll be these little shops where you're like, oh, I want like a 30-to-1 3-volt or a 60-to-1 6-volt, and they just you can find them for this motor. There's a lot of different combinations.
And I think
The
the
thing that does
commodity
make it
motors I've seen, they already kind of are offered in a bunch of like configurations. So might even find something we need off the shelf. But with a 1S battery, the I guess does the milliamp hour capacity thing and the max current output would be the other parameters to think about, right?
for sure. So keep in mind that's a totally separate, independent thing from the rails on the system, right? Because the energy coming out of the battery is never going to change. And in fact, if you're converting it up to a higher voltage, there's an efficiency loss. So you'd actually have to drop more power out of the battery if you were changing the voltage, because there's losses in the system. So the pulling it straight off the battery is the highest efficiency method. And if the battery is too small to supply the current coming straight off the battery, this is a battery is not being small problem. It's not like it's not about the motor being too large.
They're independent variables. You pick the voltage you want to drive at. So simplest is 1S, and then you pick the minimum big enough size to drive everything. Are there current limits? I know Eric did a session on like the C ratings and things like that. But are there like thermal or other problems that limit how much current you can draw from a 1S battery or something like that? Like I would say if it's two motors and plus a board plus a couple of other things, we're looking at like 3 to 4 amps total, right? At peak, something like that.
Yeah, absolutely. It would be prudent to have a little spreadsheet going that outlines the peak and continuous pull off the battery. For these little motors, I can't imagine you would ever be able to hit that. The one thing you do have to kind of watch out for, though, is if you are going to run it off the battery 1S, and this MCU, this chip is going to be a 3.3 logic rail. If you're running that logic rail off a linear regulator, and if that linear regulator is on the battery rail, if that battery rail is sagging a lot, it could potentially be an issue where you have a brownout condition. Or just not even a brownout, but just like a voltage instability condition on the logic rail, which is like, if you're not designing for that, like this can be a notoriously annoying thing in like any power electronics or inverter involving like you have something that uses a lot of power over here, and then you have like logic that needs to be on a very stable voltage reference to do its job. You can have a lot of problems.
Does it make sense to like segregate two completely different power circuits, one for logic, one for motors and other like variable loads?
That
Like
is
two
the
batteries.
absolute standard practice every time. Yeah. So that's what I mean. Is like if you have a linear regulator, that would be like this would be the logic power domain, because you have the main battery, right, which is unclean, and then you convert that down to the 3.3 power domain, which you would stabilize with like capacitors and other capacitors and potentially like filters and stuff. But you have like your unclean battery power that could be doing all kinds of crazy things, and then you have your logic power domain 1, digital power domain 1, and then you'd keep that nice and clean. But any sort of modern product, I mean, if you look inside like like a smartwatch or something, there's usually like upwards like a dozen power domains. There'll be like 3.3 volts, 1.8, 1.5, 1.2, 1.8 volts for all the various chips and ICs, because all these modern, like, very small process node chips, they have very, very, very low voltages that they're working on. And then some of the other modems and stuff will have different power domains. And then if you have analog signals, you want those to be especially clean. So you'll have dedicated analog power domains that are super filtered and away from the digital, because the digital is very unclean if you're taking analog measurements. But it's very standard to keep these domains separate.
So the simplest version of this is you have a large enough 1S battery and you run off the dirty power for the motors, but then you connect it to like a sort of capacitor-based cleaning circuit for the digital. And if you have big enough capacitors, it kind of is good enough. But if you want to do more, you'll need a secondary battery, sounds like.
That's not usually what you would do. You would always just have a primary. Well, let me back up. In some cases, yes. The only time it usually merits having a second battery is usually for this kind of an application if you're going to have a real-time clock. So if you need to have some kind of very, very, very long life, completely isolated system to do things such as keep time, you'd have a battery in there to keep the time. And this was and is still pretty common in like computer motherboards and stuff, is you'll have a little battery in there to keep the time. But in this case, if we're not doing something like that, no, you wouldn't add a second battery. That would be a cost and system complexity issue. If you're having issues with like the voltage sagging and brownout, you would go to a 2S battery, so you have more headroom. So you'd run at 7.48 volts, and then you have a lot of headroom. Because like if the battery rail were ever getting down to 3 volts, you got bigger problems. Yeah,
But
so
this means you need
that way you have
balanced
more
charging, right?
margin. Yeah.
So you need balance.
But then the charging circuit changes, right? You cannot use a 6-volt solar panel directly then if you're using the 2S battery.
You can, but you would need to go to a bit more sophisticated solar charger. You couldn't use just a linear, drop down charger. You need a switching charger, which you could totally do. They're just a bit more expensive and complex. So you do like a boost charger, a buck boost charger. They can deal with the voltage being above or at the same value as a solar panel. Because linear always stepping down, right? Higher voltage, lower voltage. If you need to go to the same voltage or up, you need to do a switch mode power supply that can go up or sideways.
Does that mean it's pulsing at a higher voltage instead of a continuous? It can't apply at a continuous high voltage.
Yeah, it's using an energy storage element, inductor or capacitor, it switches at high frequency and it boosts the voltage up. Yeah. But it's just those tend to be a little bit more complicated, and especially if you're designing your own circuit board, they can be a lot more fiddly.
Oh, we are 6 minutes past the hour. I do have to punch out, but
Yeah.
Great to have you back, Joshua.
Good to see everyone. Yeah, I'm gonna try,
Yeah.
but yeah, it's good to see y'all, and yeah, it's super cool. It's still going.
Yeah.
Okay.
All right.
Bye.